Hey guys, welcome back to Swat Studs. Today we are going to continue our base shader development. In this tutorial, I'll be showing you how you can create breakups on diffuse, specular and bump maps with procedural nodes like fractal. And also I'll be showing you a method called tri-planar projection where the texture will be projected onto the geometry like a 3D texture so that we don't have to worry about UV seams. So let's start. Now we'll start adding some breakups into the color. So for that we'll be using a fractal node. So here is where we going to add some procedural nodes to break up the textures, and because this one has no particular UV setup and it is possible that we'll get into some trouble like UV seams, we are going to do it with a method called tri-planar projection. So we have a node called AI triplanar on Arnold, which is like the same thing which we use to project textures onto the object on texture softwares like Substance Painter. So we'll be using the same method here to, create the same effect. So for that, let me just create a fractal node first. And now I'm going to add the AI triplanar node, and I'm going to connect the fractal to the input of the AI triplanar. And so the code space is with reference to what space the textures are getting projected onto that particular geometry. So if I set it into object, if I move the object, the textures will be moving with the object. If I set the code space into the world, the texture will be static on a particular position, and if I move the object, the texture will stand exactly there and the texture float if I move the object. So the thing to remember is that if we need to animate the object, then it's better to use the code space object for that particular object. And if we have no animation or if we have no movement on that particular object in any scene, then you can use world also. So usually prefer to use the object code space for any particular object. So let's just see this map in any of the AOVs to get an idea. So let's just isolate that particular node and see how it is coming. So you can see by default it is coming to be very small. So let's just reduce the scale to like 0.1 or something. So you can see how the details are coming. Now let's just reduce it again. Okay, now see, we can properly see some breakups here and it's coming really nice. So let me just adjust some attributes here to see more breakups. So I feel like this has gone a lot bigger. So let me just scale it up a little bit. Okay, so now we have the texture. Now let's see how we can add it over the layers to create some initial breakups on that particular colors. So you can do it in two ways. Either you can add it straightly into layer 4 and adjust its opacity with operation or mix, or if you want separate control of that particular breakup on each color, you can create a separate AI layer here and you can connect all these into separate inputs and you can control it through the mix with the vertex color mask for red, green and blue, and then you can add this onto the layer. So let's first add it onto the layer 4, and now what I'm going to do here is I'm just adding a AI range to the triplanar, and I'm adding the range into the mix 4. so that I can control the range of that particular triplanar values. So I can from here I can adjust the intensity of that particular mask, and I can also change the other properties like the in and out values, so that we can crunch this breakups a little more. I usually always add this AI range to any procedural map so that I get more control on the contrast of that particular procedural mask. Now I am going to use an operation called multiply, so that the layer which we have added on top will multiply with all the layers beneath that particular layer. So we get this particular output. Let me just bring it back to, and now we can control this mix with the AI range. So if I add the reduce the output max, the white values will reduce, and the amount which is getting multiplied, or the intensity which the object is getting multiplied, will eventually reduce. So this is what we want. Like, we need some breakups to be visible, but it should be very subtle. It should not dominate that particular color in any way. So it should be a subtle breakups on the overall color. So I guess this one is working fine for me, because it's not really, there is some breakups, you can see some breakups, nice breakups here, but it is not totally visible like on which is on the, like on the red part. So I feel like it should be a bit small. It needs to be smaller than this one. So let me just adjust, let me just save this screen render, and let's just reduce the size again. Okay, now it got bigger. Okay, so let's go 0.04. Okay, not too much. Yeah, I guess that is better, but let me just adjust this range also a bit. So yeah, that looks okay to me for now. And now what we have to do is, usually the process is like, if there is any breakups on the color, it will eventually gonna affect the specularity also. So whatever colors or textures we add into the diffuse layer, we'll need to add it onto the other layers also. So let's just say that these are some dirts or some patterns or breakups on the metalness, which will affect the metallic property of that particular geometry. And wherever we have this pattern visible, it will affect the metallic property of that particular object a little bit. So it's not just metalness we are talking about. If there is any breakups we are adding onto the diffuse color, it will automatically affect all other properties also. It can be metalness, it can be specular roughness. If there is triplus, it can be triplus, refraction, etc. So only in the 3D software, we are seeing a particular shader in its separate forms like diffuse, specular, refraction, etc. So in the real world, it is actually not separated like that. By science, we are separating it to, understand it much better. In the real world, when, let's say, for example, an object gets a scratch, the scratch will peel off the upper layer. So maybe some material or another layer of that particular object will get visible when the upper layer gets peeled off. So it will change its properties there, like the color might be different. With the scratch, we get some bump information because the surface got peeled off. And then when the surface gets roughened with the scratch, so the specularity will differ. This is what we are trying to create with these each breakups. Let's try creating the fractal breakup into the metalness. So here we are going to get into a trouble with the aiLayerFloat, because in the float, if you see, only the yellow and iron parts have white color and the red part is on black. So if I connect this channel into the material layer on the metalness layer, what will happen is I'll have to remove this breakup from the black parts or red parts of the material, because we don't want any gray value information on the red parts, which will create some metalness values on that. So I don't want that on the red part. So if I can show you what will happen by adding this. So we created here, we have added this on the mask or mix, and then we have added some values here to multiply it with the actual color. So if I do the same thing, like if I add this map into the mix 4, and then if I add some value here, you can see the red part also gets affected. So to avoid this, I'll have to mask it only to be visible on the yellow and the iron part. So that creates a lot of additional nodes onto our workflow, which can be avoided if we are using aiLayer RGBA here. Because the same way where we have added this and we have used multiply operation here, the same way if I used multiply option in here also on the metalness, if we have aiLayer RGBA here, so any value which gets multiplied to black will give us the value 0. So I don't have to worry about the red part, and any value gets multiplied with the white, we'll get some in-between values like gray values. So it will create a breakup on yellow and the iron part, but it won't affect our red part. So that is what we want. So this is why I said earlier that why I prefer aiLayer RGBA for all the attributes, because most of the times we need this operation on our layers so that we don't need additional layers for the masking purposes. So let me just quickly create an aiLayer RGBA and connect it to the metalness. So we already know that the base layer is red, which has a value of 0. So like we add the input value here, we can add the same value in the luminance or value of the color here. So we are only going to use a single channel from here to the metalness. So any color we are adding doesn't matter. If we put any hue value or saturation value, it doesn't going to affect the metalness. We just need to worry about this value. So I am going to leave this value on 0 because the red part is 0. And on the second layer, we will be adding yellow. So let me just quickly take our red channel from the vector and put it into mix 2. And let me just put the value here to 1. And the operation will be overwrite. And layer 3 will be our iron part, same as yellow. It has white value and the operation will be overwrite. And we'll connect the green channel into the mix 3. And let me just quickly connect its out color R into the metalness. So let me just quickly save this render and we'll see how this one looks. Now you can see the aiLayer RGBA is exactly matching to our previous aiLayerFloat. So I can delete this one, we don't need it anymore. And I'm renaming this one into aiLayer RGB. Okay, So now we can add this our fractal breakup into the metalness. So for that, I'm going to create another AI range because I need the full range value of this triplanar on the metalness so that I can adjust it further, because we have already have an AI range for the diffuse, but you can see we have adjusted its output max to 0.2 so that it doesn't get doesn't much affect the value here. Or you can, what you can do is you can leave the value as it is, and then you can adjust the diffuse layer multiplying color. So here we can increase the input value which is getting multiplied, which eventually darkens the output. So before that, let me try to match it with the previous output. So let me quickly save a render, and then we can try to match it. So it's closely matching. That's what we need. So we can use the same AI range to the metalness also. So I am enabling layer 4 and I am using the same AI range red channel into the metalness. I'm connecting the red channel to the mix 4, and I am using the operation to multiply. So let's isolate the metalness channel here and see how the output is looking like. So see, if I put this value into 1, then there won't be any difference because the given multiplying value is 1 and already the value we have here is 1. So 1 multiplied by 1 is 1. Any value less than 1 will create that particular. If I put the value 0.79, we'll be getting around 0.8, 0.7, see 0.819, that kind of values on the metalness. So let's see how the final output looks like. So if I used really less values here, it will create very crunched breakups here. That's not what we want. It will create if you see here, because of these crunched values, we are getting a lot of diffuse information into the shader. That's not what we want. It should be very subtle. So I'm adding a value around 0.8 that gives us a good amount of breakups on the specular. So if I check it here, it will be clearly visible on this part. So let me just reduce it a bit more because it feels a bit too much on the hand parts than the head. Okay. I guess I can leave it on 0.8. So yes. And now let's do the same thing for specular roughness. So here also, with the float values, it will be hard for us to adjust the roughness values of this fractal map into the layer. So suppose if we have this blend options like operations, what I can do easily here is add the fractal node into the specular layer 4 and then put the blend option to plus. So wherever we are adding that particular mask, it will increase the roughness of that particular area with reference to the below layer. So if I add this fractal breakup into the layer 4 and use the operation or blend mode to plus, then what it will do is it will plus whichever value we are adding on top or on layer 4, it will add that particular value to this input values of the material. So suppose I'm adding a fractal value of 0.2 here. Let's say if you see here, the fractal value here goes around 0.7, 0.5, that kind of values. So let's say if I add a value of 0.2 here and we use this fractal as a mask or mix on the layer 4, then wherever we have this white part, it will add the 0.2 value with this default values. So if on the red part we get the default value 0.2, then wherever we have the fractal mix, it will add another 0.2 value from the layer 4 on top of the this 0.2 value, which will give us a 0.4 value. So it will become more rougher on that particular areas. So let me just show you this very quick. So for that, I'm also changing the aiLayerFloat specular roughness from here to layer RGBA. So let me just quickly copy the values. So red, yellow, IN, then fractal breakup. Okay, the red has a 0.2, then 0.1, 0.35. So I'm adding the same values to each color here. And for now, I'm just adding a 0.1 value for the breakup. Let me quickly add the mix also. Mix 3, and the fractal will go the range. You can see I am taking the range of the fractal to the mix. So mix 4. So the fractals white and black values will drive the layer 4 here. So this value will be added on top of all the other values wherever we have white values. So let me add this red channel into the specular roughness, and so let me quickly see how that is looking. So we haven't added the operation here. So I'm adding the operation to be plus. So you can see the values we got. So here we have forgot to change the operations on other layers also. That's why it was giving different values. So this is the power of operations, because in any other time, if I want to change this red roughness to be something else, so the fractal is adding on top of the red and it is plussing the value. So if I change this to be more glossy, top layer fractal value also gets reduced according to this bottom value. So let's see, you can see here the fractal value on now is around 0.3, 0.25, 0.29, and if I increase this, it also gets increased with that value. It goes around 0.6, and if I reduce it, then it gets reduced with it. So let me just keep it 0.2 here. So if I check the roughness now, you can see we get some breakups on the roughness here. So these kind of smaller breakups brings more realism on the shaders, because all the real world materials have these kind of smaller breakups. So this is looking nice, but this is kind of feels too much. So I am going to reduce our fractal breakup value to be 0.05. It is subtle, like here the specular is totally flat white, and if I enable this one, we can see a kind of a smaller breakups which breaks the surface much better, and that's looking pretty good for me. For now, maybe I'll increase some more, 0.07, which is kind of okay. And now if we want, we can also add the same value, or we can also add the same fractal to the bump, which will break the overall surface a bit more. So on that, we have to create a control for each part separately, because the bump on each part can't be the same because the materials are different. So the surface bump also be a bit different. So for creating each material's bump separately, we are going to use the same method. We are going to create a layer for bump, and then we'll use the vertex color mask to create each layer's mix, and we'll use the same map, triplanar or the fractal map, on all the input, and we'll control the amount of bump through the mask. So now let's add some bump into our base shader. So for that, I'm creating AI bump 2D node, and I'm connecting its out value. We can get it from here or also from here to normal camera. So this will be our base bump, and I'm creating an AI layer RGB again for the layering of that bump, because we'll need different amount of bump on red, yellow and iron parts. So I am adding this into the bump map, only the red channel. And now we can do this two ways. We can create AI range for 3 AI range for this fractal, and we can connect it into 3 inputs, and we can change the output max of the AI range so that it will increase and decrease the bump value on each particular layer. Or we can connect the fractal straight into all the 3 layers, and we can create AI ranges for each masks. That way also we can control the 3 bumps separately. I am here preferring the second method, which I'm going to connect an AI range to each of our vertex color masks for red, yellow and iron parts, and I'm going to control that mix for controlling the bump. So since we are controlling bump from layers mix, we don't need to adjust this bump height value, so I'll put it onto 1. So we will not be changing this value from here. We'll be controlling each bump from the layers mix. So our base layer will be again red, second will be yellow, and the third will be iron. Now I'm going to connect the triplanar input into each of them, and then let's just change the operation to override. So we don't need to connect any map to the red because it is the bottom layer. We can control the bottom value straight from the mix. So let me just first start adjusting the red parts bump. So by default, you can see if you come to the normal value, it is too much now. The mix value 1 is too much. So let's reduce it to symbol values like 0.01. And now this one is also, I feel, too much. So let's go 0.001. I think it is not, yeah, it's there, but what I'm feeling is that the fractal values are too high, or the details of the fractal is too much for this bump. So that is why it's getting this very crispy details, like pixelated details. You can see, you can differentiate each pixels from here. We don't want these kind of smaller crispy details. What we want is a bit of a smoother detail, because this is a painted metal, or some painted or metallic surfaces which are very huge. So we'll need details which are a little bit bigger than these, because these are like micro details. We don't want to go like that kind of macro or micro levels. We'll need to see some bump details, separated bump details on the mesh. So for that, what we can do is we can duplicate this same fractal here, and we can connect the same place 2D texture. Now what I'm going to do is I'm going to adjust the level max and ratio. So these two things are the attributes which controls the details or depth of details on the fractal node. So I'm reducing all those details, and I'm also duplicating the triplanar node by pressing Ctrl D on the keyboard. And now let's connect this to the layer. Let's see how the details are coming now. So if I compare these two, you can see all those crispy details or those micro level details are now gone from our new bump. So I can now try increasing the values, and let's see how the normal map is looking right now. So with this 0.005 value also, we are not getting any bumps here. So let's go 0.1. We are getting something, so it's too much now. So yeah, you can see now it is kind of on the middle level. So this is also too much, because when the bump values are visible too much, it gives the surface a toy kind of feel, because the toys will be very small, and when the objects are getting very small, these kind of surface imperfections will be visible a lot on the toys than the actual machineries or any cars. So you can see the difference of a toy and its original object looking at these kind of imperfections and surface properties. So I'm going again to 0.02. Feels kind of too much, but yeah, this one feels to be a nice spot. Like if I increase it again, I guess I'm losing the... Okay, let's just compare a version without bump and with bump. So this is how you should work. You should compare the values with and without, so that you'll understand it better. So we have a nice amount of bump here. Let's increase this to 0.015, and I'm leaving it on 0.015 value because I feel like I'm getting enough bumps or breakups on the values here. So with the roughness value and the bump, we are getting enough breakups to get rid of that particular flat specular highlights from the shader, which increases the realism on that particular shader. So let's go back to our second and third channels, and let's add our new triplanar onto those. So now we can check how the bumps are coming on them. So yay, too much. So yeah, this. Okay, we forgot to put the green channel mix for the iron part. That's why it's not changing. So now let's go with 0.015 first. It's looking nice. Let's try increasing it. So this is more visible on these parts here. Yeah, here we can clearly see how that one is looking. It's really too much. And since this is a metallic plate. It tends to be smoother than the painted metal because it's a gold plate and more reflective. More reflective means the surface is more smoother than the rougher surface, so it will have lesser bump than the more rougher red part. So we'll have to decrease it to be very subtle, very subtle than the red part. So I'll put 0.005. So kind of getting a good amount of bump, I guess. Maybe this is also the roughness breakups we are seeing and also some amount of bump. So if we are not able to judge a shader with a single phase, you can try rotating the whole image, so that we'll get a good judgment on the shader by rotating the shader. So here now we are getting some specular highlights on the part, and we can see clearly that I guess this is mostly comes from the specular roughness. So I'll have to adjust the specular roughness again to be more glossy. So yeah, it is because of the specular roughness. And let's try removing the bump. Yeah, it's coming from the specular roughness, so we can leave it as it is for now because we have a long way to go again, and we'll be coming back when the other layers are all done, because these two are the same shader, but you can see because of the form of the surface, this is a curvy surface and this is a mostly flat surface. So that's why it has a difference in the specularity. We feel some difference in the specularity, but it's the same specular property. So I'm not liking the color of that. It is too saturated. Let me just adjust a bit. Yes, more subtle now. Okay, now let's control our last part. Also, we can go use the close-up cam, which will get a closer image, which will make the image larger, so I can get a closer look to these parts and adjust it accordingly. So for iron, what we forget is we forgot to add the AI range in between for red, yellow and the iron part. So from the vertex we have only one channel to connect to the input. So what I'm going to do is connect the red channel to all the RGB channels on the AI range input. So I'm going to duplicate this one and I'm gonna add the green channel to the second AI range. And we already know the value which we have added on the mix for layer 2. It is 0.005. So I am changing this output max value to be 0.005. And I'm gonna connect this into mix 2. And the second one I'll connect to the mix 3. So here, from here now I'll adjust the range value for iron from the range. So let's add 0.01. So the iron is mostly like the inner parts of the HulkBuster, right? So the inner parts will tend to be more rougher than the outer surface, because the red and yellow parts are more like to have a stylish appearance for the HulkBuster outlook. But the iron parts are very less visible on the overall outside areas compared to the red and the yellow parts. So these parts will be rougher, so it will show more of that iron kind of breakups or bump surfaces than the metallic yellow or the dielectric red parts. So I'm going to add more bump values onto the iron parts. So the iron's brightness is too much, so I can adjust maybe some values to make it darker. And maybe I can adjust some reflection also, like specular roughness also for this one. Yeah. And finally, maybe I'll adjust the red. Yeah, this feels more like our previous render color. So I tried adjusting more and more hues of red with this one, but I don't know, this one feels to be a good value for the HulkBuster, because the rest of the shaders, the reds are more going to the sides of magenta or pinkish and then to the orange side. It's kind of really hard to adjust or get a better hue for the HulkBuster. So we can just put back our rotation to the default. Now we have finished our base shader, and finally we can get a final output, and let's see how the base shader is looking. So we have finally finished our base shader development, and this is not the final look or the final settings for the base shader, because we will be coming back to adjust some attributes according to how the shader is progressing with other layers of shaders. Like we'll be adding scratches, edge wears and dirt on top of it. So we'll have a final judgment and final adjustment when we reach that stage, and we'll be taking more and more setups. So if we check right now, we have some mistakes here, like the yellow parts are more gone into the diffuse side, because this shouldn't be happening here. And because of that, the overall metal feel is going onto the diffuse side. So that is because of this metalness we have added onto the layer 4. So we'll have to reduce that particular value to get more of a metallic values on here. So I'll go till 0.95 and see, you can see that reduces the diffuse values from the metalness overall. So I hope we'll be getting more of a metallic values or metallic feel onto the shader here. See, it's a subtle difference, but this is more of an accurate metallic feel. So thank you for watching this tutorial. I hope it made sense. Let me know what you think about this in the comments, and hit the thumbs up button if you enjoyed it. Subscribe the channel for more future contents. On the next part, we'll be talking about creating surface imperfections. I'll see you soon with the next part. Till then, take care